This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gavin Henry, and today my guest is Daniel Stenberg. Daniel is a Swedish Internet Protocol expert and developer who has participated in and worked with open source software for 30 years. He is most known for being the founder and lead developer of the curl project, one of the world's most widely used software components. He also participates in protocol development within the IETF and has authored books on curl, open source, HTTP version 2 and 3, and more. Frequent public speaker, Daniel is employed by Wolf SSL. Daniel, welcome back to Software Engineering Radio. Is there anything I missed in your bio that you'd like to add?
I don't think so. I think that covers pretty much what I do.
Yeah, it's always very impressive reading that out for you. I like it.
Thank you.
So today our show is called Daniel Stenberg on removing Rust from curl. So what I want the listeners to get out from this, hopefully, is to understand why you wanted to bring Rust into the project, how you brought Rust into the curl project, to understand why you, I'm going to use the word abandon the attempt, but decided not to do it. Same. And what the future holds. And then hopefully help everyone understand the lessons learned. So if someone else attempts, or if you come back to it, we're all much wiser for the process. So let's lay some foundation and remind our listeners what curl is. I think you're probably the best person to answer that, Daniel.
I'm not sure I'm the best one. I struggle sometimes to explain it. But I guess it depends on, what you know and what you understand about things. But curl is a command line tool and a library for doing network transfers, really internet transfers using URLs. So it's most widely known then for doing HTTP and HTTPS, but it supports 28 different URL schemes. So including email protocols, IMAP, SMTP, POP3, and FTP, and SFTP, and SCP. So it has a lot of transfer protocols. And I could also just continue. So the command line tool is often what developers think about when I say curl. But of course, libcurl is the most widely used component, which is that's the library that is embedded and used by millions and billions of devices that are then doing internet transfers using libcurl. So one very important key factor with curl is stability, security, and in particular then ABI and API stability, that we provide a solid and stable way to use it basically forever, so that all our users in the world can just upgrade to the latest curl without having the pain of adjusting things in the ABI or API.
That takes a lot of effort, a lot of testing, a lot of work.
It does indeed.
You said it's used in billions of devices. Do you have a top 5 list of where you know it's used, just to help listeners?
By volume, I think nothing compares to the mobile phones and tablets. So it's an embedded component in iOS and in Android. So it's basically on every smartphone and every tablet that exists. And that's 7 billion devices or something.
Yeah, I was going to ask how many users does it have, but that answers that question.
Yeah, so basically I tend to avoid the word users then, because it's a little bit weird since it's a library, so it's getting used by others. So it's not really users, but embedded in different tools and applications. And a fun part about it being used in all these mobile phones is also that libcurl is a library, right, that is used embedded in these mobile phone operating systems, but they don't expose the API to applications. So a lot of apps ship and bundle their own copy of libcurl. So typical phone today, you have multiple installations of curl actually, because a lot of high volume apps also ship it and bundle it because they want to use it, but they can't access it from the OS level. So in a typical phone with a lot of apps, you have maybe 5 or 10 installations of curl.
Oh, wow. Yeah, I was going to mention that I just bought the Nintendo Switch 2. And someone listed curl in the credits to that as well. So obviously Nintendo use it.
All game consoles have it embedded as well.
And do you get support from those guys in any shape or form? Android, Apple, Google, Nintendo, or are you not allowed to say?
The standard answer is no, I don't. So I have a few customers. It's actually a few. So that's far too few than I would prefer. So most users, like these big ones, they're just using the open source version for free and seem to be happy with that. I try to get as many as possible to actually pay for support and help them use curl properly so that they can sponsor me for my maintenance and ongoing work. And not only me, of course, the rest of the team as well. But it's a hard sell sometimes.
And how many in the team do you have, full-time or volunteer?
I'm the only one that is full-time. So it's a small team.
It just blows my mind when people actually explain, critical software, critical internet software like this. And it's just a person or a couple of people. Nobody really understands that, do they, unless they're in the open source world?
That's true. And also, it sort of just suffers a little bit from the classical economic terms that if they don't have to pay, they prefer not to pay. So all of these companies, they don't have to pay. So they mostly just don't, even though maybe morally or something they should or could, but they won't.
Yeah, I think they assume that someone is, and nobody actually asked that question. I don't know. Okay, so I reached out to you because I read a blog post December last year, so 6 months ago or so, called Dropping Hyper. Now, because I'm in the Rust world and I've done quite a few shows on Rust, I know what hyper is. Could you tell me what hyper is before I move on to the next stage?
Yeah, so hyper is, close to the libcurl alternative in the Rust world. It is a HTTP and HTTPS library for Rust. Well, I think that pretty much sums it up. So yeah. It's an API to do HTTP in different ways.
So the background here is, I'll summarize with what I understand, but you can correct me, obviously. So historically, there is or was memory-related issues and bugs that come up. And the driving force was to bring a memory-safe language or version of the HTTP library in to curl. Is that correct?
Yeah, exactly. Curl is written in C, right? It's from the 90s. So it's one of these old classical styles of open source projects. So it's written in C. C is unsafe, and we certainly have our share of memory-related security issues over time. And curl also has this backend system, which means that when you build curl, you pretty much decide which backends you want, and all those backends are powered by different third-party libraries. So for example, if you want TLS support, that TLS is provided by an external library that someone else wrote that we then interface. And typically we then allow difference. You can select which TLS library you want to support and so on. And we have different backends for SSH and content encoding and different parts, IDN and name resolving and so on. So it is sort of in the nature already that curl offers a selection of different backends when you build it. So the idea was then, so curl is written in C. Maybe we should try to make the final build use more memory-safe code. And by memory-safe, then being using libraries written, for example, in Rust. Rust is probably the most suitable replacement when it comes to this. So this was actually then a sponsored thing from ISRG in their Prosimo project. ISRG being the team behind Let's Encrypt, right? And they have this ongoing project to replace memory unsafe projects with safe projects, pretty much rewriting things from unsafe languages into Rust. So they sponsored this. So the idea was then that we would introduce a new HTTP backend in curl that would be powered by Hyper, the Rust library. So by building curl with this HTTP backend, we would get a build that would then use more memory-safe code than we would otherwise have. But it was then an optional build, right? So you could either use the native C version or use the Hyper-powered version.
Yeah, so just to summarize, you've got the curl project that can offer 28 different protocols, depending on what you configure when you're compiling it, or what's available on the operating system or the build environment. Those protocols will then have a backend. So say you did, well, we're talking about HTTP. So HTTP, we could opt to use the original one in curl and C, or another one if there's one there. And the same for like TLS. You could use different libraries to provide that protocol capability.
Exactly.
Because traditionally you've had a lot of memory safety issues. Rust was the current offering today that would make sense to bring in. And obviously a rewrite in Rust, as the term is, or a rewrite in anything would just be insane. So doing it bit by bit like this is the...
Exactly. It's pretty much the only viable way forward to introduce more memory safety, that it is to use more and more alternative backends and backends written in memory-safe languages. So that was sort of the idea, that we would then do it this way. Or we did it too, so it was more than an idea. It was actually also made a reality.
And how did you decide Was Hyper like the number one Rust offering, or did you have some criteria? Could you give us some examples around that thought process?
Oh, it was actually not that much of a thought process because, well, I'm not that much into the Rust ecosystem and the Rust world, really. So I actually went pretty much with the suggestions from the ISRG people. So Josh and the guys there, and I talked to Sean MacArthur, who's the lead maintainer of Hyper. So it was actually a pretty quick process that we deemed it seemed like a suitable library to use and at the appropriate level, sort of the abstraction level in the stack. So we deemed it a suitable thing to build on and with.
Okay, so you had guidance. What does that stand for? Internet something? ISR?
Internet Security Research Group, I think. It's something more or less nonsensical. Well, it's they Let's Encrypt. That's what they did.
Yeah.
They created, I think it's a foundation or something. It's a nonprofit, something ISRG.
Cool. And they sort of gave guidance on that. And
exactly. And they sponsored this work, right? So we could sort of back and forth a bit on exactly their idea and my idea and how we could make that a reality. And then I talked a lot with Sean as well.
And Sean's the maintainer of
Hyper.
Yeah, Hyper.
Yeah, exactly. Because when I started this, so curl is written in C, right? And Hyper is written in Rust. And while there is a way, and this was years ago, we started this, so I needed a way then to interface Hyper using C. So I needed a glue layer to make sure that we could use Hyper properly from C. And that didn't exist back then in Hyper. So I had a lot of back and forth with Sean about that and creating that while doing this work in curl. So it was a lot of, we had to do the work in several different places, actually.
Yeah, so it wasn't just, here's a Rust library that has a foreign function interface ready for C to use on the shelf, and you just grabbed it. There was a lot more to it.
Exactly. It was pretty early work in doing this. So there was a lot of moving pieces, actually, that had to be done to make it work.
Yeah, and the FFI sort of landscape has improved quite a lot in the past 5 years, hasn't it? Because I'm using it myself in another project.
Yes, exactly. It has subtly improved. Since we're also using, since I mentioned all these different backends, you can still build curl with other Rust backends. So we support Rustls, for example, the TLS version from Rust, and we support Quiche, which is a HTTP3 and Quick library that's also written in Rust. So there's still ways to build curl with Rust-powered backends. So I'm still touching that world still.
Oh, so it's just Hyper that you removed, which provides the...
Exactly. So we didn't actually remove all the ways to do Rust. We removed Hyper. And Hyper was actually the only HTTP backend. The other ones I mentioned now are TLS backend. It's a TLS backend and an HTTP3 backend. So different places they glue into the stack.
So Hyper was HTTP 2?
HTTP 1 and 2.
Oh, 1 and 2, yeah. Forget about 1. And because it was funded by them and they gave you guidance, helped not have to make a lot of decisions with what you're picking. So you didn't have to start protocol parser from scratch in Rust.
Exactly, because that was really never a good idea. So because that's quite a lot of work. And I'm not really a Rust guy myself, so I wouldn't be a suitable person to write it in Rust anyway. And by using something that was already there, proven working and everything, I would say it was a pretty suitable option to go with.
Yeah, because as I understand it, when you're talking about bringing Rust in or rewriting Rust or porting to Rust, the options would be what you've done. You bring in something established or you port the C code. You look at the C code on one screen and on the other screen you're rewriting that C in Rust, which it does work and it kind of doesn't. There's the Rust idiomatic way, which I've done a show on that, by the way. Most of my year has been spent on Rust stuff, so I'll just list a couple of shows for the listeners. The latest one was show 672 on Rust in production with Luca, 670 with Matthias on prototyping in Rust, which was really enjoyable. And then we did show 659 on idiomatic Rust. So there are some other ones for people to listen to. Anyway, so creating it from scratch or porting your C code to a Rust equivalent was just insane. And just to close off this section before we move on to the actual process of what you did, how do you see most of the memory-related issues in curl? Is it in your implementation of the HTTP spec, or is it just spread across different backends and different integrations? Where do you see the most pain?
That's a really good question. I actually don't think I've had them mostly in the HTTP-related parsing code. So it wasn't really addressing where I think I had the most, but it's really hard to find that pattern, right? Where do we do the most mistakes and how do we fix them? So typically when we get security problems, we of course try to see the pattern and see what we can learn from that and what we can do to avoid them in the future and so on. But they tend to be spread out in different ways. But also, we have also, over the last, I would say, maybe even 10 years, we have done several different things internally in curl, sort of to make it harder to do those mistakes we sometimes did in the past. So I also think that there are many ways that we can actually just write better C to avoid some of those mistakes. So there are many different things that are happening at the same time. So at the same time, we try to maybe introduce more Rust code. We also made sure that we did better C code and avoided some things that obviously things that were a little too easy for us to do wrong and insert mistakes with. So nowadays we sort of introduce more internal helper functions and rules on how to do things just to avoid the risk of mistakes more.
Yeah, trying to centralize where you do some of the risky things.
Exactly. For example, like that, yes.
I follow your blog and whenever you're doing stuff on LinkedIn or what have you. And I think there was a bug that was like 20 years old or something, wasn't there? That came out of nowhere because it was some obscure usage. So there's always stuff lying around.
Yes. Security is really hard.
Yes. And saw your post about, I'll put this in the show notes, about all the new AI stuff coming through, reporting security, memory issues. That's all just made, well, it doesn't make sense, the stuff that is getting submitted.
No,
doesn't
exactly.
relate to the code.
Yeah.
But on the flip side, maybe there's something there that can do some analysis to try and find some type of correlation. But I think we've kind of lost the trust on some of that at the moment. So there's a bit of work to be done there.
Oh, yes. Yeah. Of course, the dream is that these tools should be able to find problems because in theory they should. But I think we have more work to do before they can do that reliably.
Yeah, I always imagine them just kind of walking through your code, running some tests, generating fuzz tests, doing all the stuff that we all hear every day. And then it just gives you a nice little summary report saying, oh, by the way, we just did this weird thing and found this. And you're like, oh, thanks. But yeah, I don't know. A wee bit away from that.
Yes.
So let's move on then. So just to close that off, Hyper is the sort of most popular established, not the only one, but the one that you were advised to play with. You didn't start from scratch because that would be insane. And this part of bringing Rust in wasn't trying to solve the most or a really common memory-related issue. It's just something that was the right way to start.
Exactly. And the idea was then, since we already have this concept of different backends, this would be one more way to just bring in another backend and then replacing native code. And we could then, in theory, introduce even more backends in the future, right? Replace more parts of curl by creating new backends that would be written in Rust. So in theory, that could, over time, be more or less that rewrite to Rust that I wouldn't do, but it would be another way to do it by just replacing component by component over a long period of time.
So is this the only bit of Rust that, so we've got the backends that implement the protocol that you're providing. Because this has been pulled out, is it only the curl implementation that's left or is there other ones?
Yes.
Yeah.
So basically I created this HTTP, the notion of an HTTP backend, it didn't exist before this. So I created it on the behalf of being so that I could use Hyper for it, Hyper or native. And then when I removed the Hyper approach, there was no other backend. So I pretty much closed that door. And now we don't have any HTTP backend anymore. We just have the native code for it.
Yeah, I think I read the removal history in your Git repo where you closed all the options.
I also think part of the lesson by the whole Hyper journey and adventure, part of the lesson there is how we should do such an HTTP backend the next time we try it. So I think it was a little bit weirdly done. And I think that's also one reason sort of why I removed it completely instead of leaving it open for a potential future. So it wasn't really done the best way. And we have since remodeled internals and actually improved a lot of things, refactoring the internals of curl and libcurl. So I think the next time we try to do an HTTP backend, we're in a much better position and we have more knowledge and we would do it slightly different and in a better way that would sort of hook into curl in a more future-proof and less hacky way.
Yeah, I guess it's not a standard backend that you're doing a protocol for. So that sort of journey from the core of libcurl to calling the backend hooks or however you do it would have been completely different and brand new.
Exactly, because we learned a lot from doing this and now we know more.
Yeah, so it's not a failure, it's just a learning process.
Yes, absolutely.
Okay, that brings us nicely on to actually adding Rust. So I haven't done this myself. I have a bit of an idea, but I just want to paint the picture of what it was like before you even did this. So normally when you configure, it's an auto tools based project. So that's your configure, make test. Is that correct?
Yeah, pretty much.
And you have a CMake option as well, do you?
Yes. Yeah. It's pretty much on par. So you can select whichever version.
Yeah, so you're doing the configuration part, running your configure script. So we'll stick with auto tools. You might do -- help and see how you build things, what options you do in. And at that point, 2020, there was nothing in the configure AC script that lets you detect what's there, what's built, nothing to say, build this or that. That's correct, yeah?
Exactly.
Cool. So then there was no variable set to then act on to say, right, use this code instead of that code, or compile this code or that backend, or check Rust is installed, or the Rust ecosystem is available. Correct?
Exactly.
Yeah, so really ground zero.
Yes.
So how did you start this process? And can you give us an example of what that looked, time period, what bits you tackle first, if you can remember?
Whenever I want to start to support something new like this, I typically I start with making sure that we can detect it with configure. So then I add my configure rules first so that you could add the -- with hyper and provide the installation path. Pretty much like whatever, since we can support, again, you can build with different backends. So the same way you would decide other backends with the configure line, you would decide this backend. So you would specify, I want to use hyper. Hyper is installed here. And then I would provide the proper configure magic so that it would detect that hyper actually exists. It is the proper version. And then I made sure that you would build with it. That's the easy part, right? That's just making sure that the library is there and can be used.
So how would you do that with Rust? Would you need to create a little Rust program and then add the hyper module? Or?
No, pretty much, since we need the FFI version, it wasn't even the generated FFI. It was a glue library that Sean created first. So pretty much, I don't actually interface the hyper library directly. I interface the little glue library or wrapper library called something else. And that's the library I check for, because that's the library written with a C interface. And so I just pretty much make sure that I can find that library, link with that library, and I can find a symbol in there and I can link with it, that I deem it suitable and working.
Yeah, that's what I've done in my project. And I'll explain how I understand it. And I think that's how you've done it. So when you build a Rust project, you tell the cargo or the Rust ecosystem to build that as either a static or shared library. It's not going to be a binary. And then install that somewhere. And that's what you're trying to detect, isn't it? And then saying this function should be available through that library. And then that means it's installed.
And then I make it just a set to define for that. And then in the build, I can just use an if-def. If this is available, use this code. And if it's not available, use the other code.
Yeah, cool. That's how I understand it. And hopefully the listeners get that. So, yeah, I mean, Rust can be built into a library and offer a foreign function interface for C code, i.e. FFI, and that's what you're doing.
Yeah, and then it was just a matter of, splitting up the code in a suitable way. So what can Hyper provide, and make sure that I would abstract it in a way so that I would either use the native code or the Hyper library to do things, setting up a request, adding headers, parsing headers, all that stuff you do with HTTP, which actually is quite a lot.
And did you, as far as the core was concerned, it's just a C library you're using. You didn't have to think about how Rust did something.
Exactly. That's kind of the beauty of it. I didn't have to think about it as Rust at all. I just have an API, and that's just an API I get to use. And it doesn't matter how it's powered, right? Which language is written in or anything. I just have an API to use and call.
It could have been any language, really, but we wanted Rust because of the memory.
Yeah, exactly. It didn't matter to me, right? Whatever language it is written in, it doesn't matter. I have an API with a documented behavior and expected outcome and input and everything. So I would just use that. And of course, one of the challenges for us then, me and Sean from the Hyper side, is that this was early days then for the FFI things, and me using Hyper from a C program. So most of this stuff didn't actually exist. It wasn't really documented. So we had to have a lot of interactions for me to understand how to use it. And one of the challenges actually in general when it comes to using Rust from C all these FFI things is that most of the documentation, even though Rust provides this as a sort of a fairly convenient way to generate code so that you can use it from C, is that most of the documentation written for these Rust libraries, they're written for Rust consumers, right? Rust users quite naturally. But it makes it complicated when you're not using the Rust API, you're using this FFI API from C, because then you end up in a weird middle land. You have to read a Rust documentation, but it's not that way. It's actually exposed to me because I'm using the C API.
Yeah, normally the sort of standard way to do this is you create a Rust crate and it's got a suffix of -sys, so sys. That's the bit that links to the C library. And then you've got a nice Rust idiomatic crate that links to this sys thing. So you're hiding all the C stuff.
Exactly. But the documentation.
The way you do it is you've got to generate the library, and then all the Rust doc things are documenting the symbols and the function calls and the return types, because it's strongly typed on the Rust side. And I don't think that has an ultimate way to do it. Maybe through bind, gen, and libc that offer those things the other way. You said that Sean, so Hyper was just Rust, wasn't it? It just was a library for Rust. It didn't have anything built to generate the C build.
No, but it was already in their plans. So I really didn't sort of push for anything they hadn't already intended to do, or it was just that they hadn't done it yet. So I was pretty much the first user of it.
So did you have to work together to create function names that would be available through the library version of Hyper, the C library version that you would call?
Yes. Yes, because since it didn't exist, so they pretty much had to go through it one by one and make sure that I could access it from C and provide the documentation for the C angle, which is an interesting challenge, right? And I think that was one of the bigger challenges in general when it comes to doing this, is that in this middle land, when there has to be a C library or C interface to access from the C code that would then reach into the Rust code, it means that you have to have someone that is actually interested and knowledgeable in both languages in that middle land to understand it and be interested enough to work with it and write the documentation and provide the functionality necessary for this to actually work.
Yeah, because it's double the work, isn't it? Because you've got to design the Rust function, then you've got to say on that Rust function, the standard way we do it in curl, I'm just guessing here, you've got to return a exit success or an exit failure, or a pointer to an error code, or both, saying, right, if it's a non-zero return, then, what's that? So there's loads of things to think once you've actually written, well, how is it called? And how are we going to provide what curl needs? And you lose a lot of Rust's main features, the rich error code you can get and all those types of things, because you're squashing it down to a 1 or 0 or a pointer.
Yeah, exactly. So it has to be sort of translated into the C world somehow.
And we've already said this was opt-in. Can you recall what issues you immediately saw as Sean was working on this interface layer? Or
Well, I think one of the primary first things that we struggled with was the inherent async nature, at least that Hyper is written in, so that it made the API quite unorthodox when it comes to how normally C interfaces work, because they have a completely different approach to how things work internally and how they were exposed. So it was a steep learning curve for me to understand how to actually even use the API. But that was more of a just getting to know how things actually work. I guess that just comes with the territory when you have to use a library that is fairly rich in features and you have to integrate it. One of the biggest challenges for me in general when doing this is that we have a pretty extensive test suite in curl, and it's getting, increasingly more and more tests over time. One of the things we do in the test suite is that when we, for example, verify HTTP1, when we do a request with curl, we verify that the outgoing request is exactly as expected. Every byte in the request has a specific value it's supposed to be, right? So outgoing request, we know that if it's 120 bytes, we know we can compare it. All those 120 bytes should be exactly like this. And the same way, when we get a response from the server sends back a response that might be, I don't know how many bytes, but all those bytes should match exactly when we download it, exactly as the server sent it, or as curl saved it. That actually introduced quite a lot of interesting challenges, because Hyper has a different approach to how they expose HTTP details. So suddenly it was not at all that as easy to do the test cases the way we had done it for decades, because Hyper exposed it differently. So it was already there was a challenge to make sure that how do we verify that a transfer done with a native code is identical to a transfer done with Hyper.
Yeah, so you haven't got that safety net to fall back on to just, if that test fails, you know you've not done something right. You've actually got to change the contract between.
Yeah, so part of our first sort of steps into making sure that this would work, it was that we had to ask Sean to do several different changes to Hyper so that it would provide data in a more curl-like way so that we could actually use it in the test suite and make sure that the requests were not completely identical, but almost identical enough so that we could actually tweak the test suite a little bit so that we could run tests and make sure that they actually work exactly the same.
So to interface the C to the async Hyper, which I'm not sure if it used Tokyo or...
It does, I think.
So is that a ton of callbacks you have to do and wait for the reply, or?
No, I think they hide the callbacks. So they do the callbacks. It means that you do a lot of things, but you don't get to answer. I mean, you sort of start an operation, but you don't get to answer to the operation now. It just, it returns okay, but it hasn't actually performed it yet. So you have to call it again later to know if it went okay or not. In a way that was, when you introduce, like, for example, like in my case, when I want to have an alternative way to do HTTP, I have the native way and the Rust way to do it. It just introduces some fun challenges when one of the backends have a completely different way of thinking about these things than the other. So it made it slightly complicated to make, selecting the two different forks of the road and make sure that nothing else in curl would see that or suffer from that or misbehave because of the different, which of the different backends you would use. So it was just a challenge, really.
Yeah, I imagine you've got a sort of ABI or API to add a new backend to curl. So if I was coming along and I'd created a brand new protocol and I wanted curl to do it, I know there'd be documentation of how I hook that into your configure and build process. But that wasn't there for this Rust version in Hyper because you hadn't done it before. So
yeah, exactly.
You've got two moving parts to try and line up and work, and a whole new sort of frontier to try and pull things out of libcurl that you hadn't done before as well. Okay, so what advice would you or could you give others with regards to this build process? Actually, the way you've explained it is just another C library.
Yes. I think that's a pretty neat way to do it. So I think that's straightforward. And from a C point of view, from our project's point of view, it was really convenient and really working well. So technically, there's no problem. There's nothing really that I think that should or need to be changed when it comes to that. I think the biggest problem, and come back to that because I've already mentioned it, and I see the same problem actually with the other Rust-provided backends, is that, again, you end up in a weird land where the documentation is often fairly good for these Rust libraries, but they don't, since I don't interface the Rust API, I end up in a weird land where I don't actually have a documentation for how the API interface I use isn't actually documented. So I have to do a lot of guessing or reading code or both, or guessing how it actually works, because the translation from Rust to C is not always straightforward. And it's not even, I can't even guess at some points because it matters. It depends on how you actually do that FFI translation pretty much. So that's a sort of a common pattern I see.
Could you give us an example of that? Say we've got a function that does something and returns something. That function interface is documented, but what problem?
Well, typically it's only documented, the Rust version of it is documented, sure. So there's a fairly elaborate description of how it works when used in Rust, but I don't use it in Rust. I don't even understand what the documentation says about the types and how they work and everything, or even the return code, because that's not exactly what I don't pass in those arguments. I don't get the same return code. So I usually get a more of a tweaked or twisted version of that API, but I need the details in that particular flavor because I use the C API, not the Rust API.
Yeah, I see. When I've been doing some functions, I've only written them because a C program is going to be calling them. So I've changed the signature of that function and I'm what it returns. But I guess if you've got like a really
I think sometimes it's more of a case that sort of as a C user in this sort of situation, I'm the oddball here. I'm the niche case. So of course, people are sacrificing, spending spare time and offering their time on this and energy. They, of course, focus on getting things working primarily for the Rust users. So that's why the Rust documentation is the priority. And I don't argue with that because it makes sense. But sometimes that makes it harder to use it from C because this documentation is often...
Yeah, the types and the structures in the Rust side, when they tell Rust to represent that as C, you just have to kind of see what comes out, don't you?
Yeah. And then it comes back to this. To do this really well, you probably need to understand quite a lot of Rust and C at the same time. And that's a special intersection of people.
Excellent. So I'm going to move us on to our, autopsy, for want of a better word. What went wrong, the analysis here. So first question, was this the right part of curl to use Rust in?
Yes, I think it could have been the right part to use Rust in. I don't think it was actually the part of curl that was the problem because I think, as I said before, I think we can pretty much introduce backends for more or less anything in curl like this if we just spend time and energy and do it correctly. So I don't think it was the part of curl that was the problem. I think the primary thing that made us eventually pull it out again is that we didn't really find users that wanted it.
Yeah.
So we have this, I kind of like the sort of the survival of the fittest approach by offering different backends for different solutions so that users would pick whatever they want and go with that. We offer a bunch of different TLS library solutions, for example, and users can pick whatever they want and build curl and use that. And we can over time detect that, wait a minute, these different ones are never used. We don't have to support them anymore. We can remove them. So pretty much letting users decide what we should have and what's used and what's best and what they want. It was quite notable quite early on and through the entire project that we had a hard time to get anyone to actually even just try out the Hyper backend. So we had pretty much no one used it. And by not having users, we also had very few contributors, helping out improving the backend so that very few people actually engaged and helped us out. So
how do you figure out if a backend's being used or is popular or not?
Basically, just by asking people. So we have annual user surveys and usually, asking on the mailing list, people are frequent users, are you using it? Or sometimes you could just notice, by when we have had a serious bug for a while and we fix it and no one has told us about it. That's a sort of a pretty big clue that no one actually used it. We also marked it as experimental, which also, of course, is a blocker for people to use it in production because we never actually got it completely 100% the same as the native. So we kept having, I think, like 3-4% of the test cases disabled because when you enabled Hyper, because we never got those test cases working exactly the same.
Yeah, I suppose you could argue if it was marked as stable and then it became the default option, then you'd get bug reports and people would opt in, would help out. But if you didn't get there, you didn't get there.
Exactly. Yeah. Of course, that was one obstacle, certainly a major one.
And were the other Rust options, the TLS stuff, was that there before you started this project? So you had some experience, or was that done after?
The quiche one for HTTP3, that was started before. The Russell's one started, I think, pretty much while I was doing this.
So that's Rust TLS, isn't it?
Rust TLS. We have a much better understanding of TLS in curl, and we have much better infrastructure and setup for TLS backends in curl. So I think that's a smoother ride and a better fit into curl. And also, I think TLS is a better abstraction layer, I think, maybe than HTTP, sort of quote unquote, because what the internal API or how to abstract HTTP away, it's certainly far from clear and obvious how to do it. And one of the challenges we face many times, I already sort of alluded a little bit to that Hyper and curl has a little bit of we have different sort of approaches to how we approach HTTP, which made it, for example, when getting the headers from Hyper, it would get them in a more or less random order, while curl always returns them in the order they were sent over the wire, which, of course, if I don't have the same order, I can't compare them correctly as I do in my current test suite. So that's one thing, for example. And other things like Hyper has certainly other limits, restrictions, requirements on the HTTP layer than curl has, which also introduced funny friction and differences when you built one way or the other way, because they would behave differently depending on just policies or religion or taste.
The existing Rust things that you're using were, again, just C libraries, but in a well-established landscape because you had other backends already.
Yes.
And this compacted it. And there must have been a point, or was there a point when you thought, hold on, we're having to make so many changes to Hyper to get this to work. Did you ever have a conversation about, oh, let's just do this from scratch because you tried it out, or was that just not a thing?
I think that also because I'm not qualified, I'm not skilled enough in Rust myself to do that, so I wouldn't do it. And therefore, I wouldn't dream of demanding it from someone else either. So it was pretty much Hyper or not at all, right now at least, sort of, because now we had this Hyper solution. This is what we struggled to get working. And I think we got it pretty far as well. So, I mean, we were at 97% of test case coverage. So I think we were pretty well on our way to get it to work. But then it flatlined and no one worked on it for a while. It just sat at that state. And we didn't seem to have anyone really interested in pushing it forward. And when it was pretty much at that state, we decided that, wait a minute, if this is where we are, no one is pushing for it and no one is really asking for it either. And all of these different caveats, and we need to do these different, maybe not kludgy, but maybe sometimes a little bit of uncomfortable or quirky solutions internally. And still, we're only at this point. So maybe that's what we should call a sort of a end of the road for this adventure and say that we didn't actually manage to do this in a proper way.
That brings me nicely on to what benefits did you gain from the attempt, which to me sound like a lot of things that you've learned.
I think we learned a lot. I think actually Hyper also learned a lot. I think they improved as well as we did. So even though when we sort of split off and we're no longer using Hyper, I think we improved curl in several ways. We made the HTTP handling more rigid and stringent to match up with Hyper, really. And we did a lot of cleaning up internally to be able to do this back-end separation. And that helped us internally to just do HTTP in a cleaner way. And then also this lesson that we learned that how we should do this the next time, pretty much. And this entire Hyper journey also coincided with other refactors we've done in curl. And I think the Hyper lesson also helped us make decisions and learn from that and use that when we refactored the internals in curl, so that we sort of have in the back of our minds, we now have this idea that when, or maybe if we do this again, now we have these different tools and setups that will help us do this better the next time.
Did any of the changes that you made to bring in Hyper, did they remain, or did you just rip them all out when you removed Hyper?
A lot of the improvements we did to HTTP in general and the separation of HTTP from other, there were some cases of pretty much of, I don't know how to sort of explain it, but that we have sort of infected other code parts with HTTP specific knowledge that we had to make sure that they were not in the generic parts, they had to be in the HTTP parts. So we did a lot of cleanups like that have certainly remained and just been emphasized and improved over time. So I would say that quite a lot of the HTTP related, the protocol related parts, they have remained. What we pretty much ripped out was the entire attempt to have this flexible back-end approach where we go either or way, because we don't have that anymore, so we don't have to provide it. So that part we ripped out.
That makes sense. In your blog post, you said, so I'm just going to quote this bit, 95% of the work is the easy part. Can you explain the other sentence that says the final few percent would, however, turn out to be friction enough to now eventually make us admit defeat, give up, and instead yank it all out again? So what, those last bits?
I think pretty much because we made everything out. We have about 2,000 test cases in total. I think about 800 of them or something, 1,000 are about HTTP. And I think we were down to maybe 15 of them failing with Hyper. And getting those final 15 test cases to work, those were the ones that sort of finally broke us, because they require that someone actually understand Hyper probably the C glue layer and curl and the protocols involved, and sometimes more protocols involved, because sometimes they also involve, actually in these cases, many times they involve HTTP authentication mechanisms too, like NTLM or digest or negotiate horrible things. So you really need a particular kind of person with intimate knowledge of all this. And not only knowledge, but you also have you need an interest and an energy enough to actually dig into this and work on this. And we basically didn't find those persons with that time and energy. So they remained there. And I didn't see any easy outcome. I didn't see anyone likely to show up to do this work. So
those 15 tests, do you recall a couple of them, what they were and why they failed?
Well, why they failed, that's part of the reason why. If we knew exactly why they failed, it would have been easier. But that was part of the research that would have been done. It's in the interaction or the differences between the hyper solution to do things to the native solution to do things. And I could also just add that hyper is not doing everything. Curl can do a lot more HTTP than hyper can. So the HTTP backend hyper provides was not everything HTTP. So there was still part of HTTP that curl did natively. For example, all those authentication mechanisms. There was this interaction or middle where curl would set up things magically to how to do HTTP, and it would use and interact with hyper to perform the HTTP requests, but also it's not easy to explain, and I don't recall the details right now, but there were mostly cases like that. And they would end up slightly different than, the requests or the responses would be slightly different depending on which solution you would use. And the entire challenge there would be to figure out why and what to do to fix it.
I think I can imagine, because I've done similar in my C project, bringing Rust into it, which is another reason why I was interested. So I imagine that the bits that curl still does that hyper doesn't or never will, you set those up, you're giving your data, so you're passing stuff that's being created as in memory, is all aligned or what have you on the curl C side of the FFI boundary. You shove that across to Rust, it has to then interpret and understand all that bit correctly, do its bit, make changes, and then pass stuff back across the FFI boundary from Rust to C and hope that bit doesn't get messed up. And then you've got the strict agreements of who's managing memory, who's doing what, who's freeing things, who's setting it up, and that can get complicated very quickly.
Yes.
So that type of interaction, because hyper is not a full 100% replacement for what curl is doing.
Exactly. And by the fact that it is doing things differently. So it was also that nature. So it was just, fairly complicated programming challenge. I mean, not impossible, of course, but it was just challenging enough that it turned out to be an obstacle that no one really worked on. And when no one had worked on it for long enough, I took it as a sign that it's probably not something people want to work on either. And no one showed up interested in doing it either. Well, people did work on it that helped us out. And we got this far thanks not only to me, of course, or to Sean, but actually also to a whole bunch of other contributors who helped out. So there were people around.
I mean, you hold very, very high standards, obviously, because it's your baby. But you could argue that it's a success. You got that far and you had 15 tests left to solve. I mean, that's a pretty big win, wasn't it, really?
I mean, I think we proved that it actually could work. It proved that the idea was solid and the implementation wasn't perfect, but it worked. So I think in that aspect, it was a win. But then in the end, we didn't go all the way. And I was also the fact that we didn't really have anyone asking for this or using this or pushing for this, there was no demand from the user side either. That was also sort of a pretty big factor because there was no, big gain in the end of all this struggle either.
Yeah, it's a feature build that if no one's asking for it, it's a feature really, isn't it?
Right. And so in the end, it felt like, there's final friction here that we could maybe surpass and go through if we really made an effort. But there was no one asking us to do that. And the big trophy in the end was missing.
Did you have a timeline by the sponsors of this feature? I forget the acronym. Did they say you had a year, 5 years, or just how did that work?
No, it wasn't really like that. They were much more flexible than the ISRG. So they were really great with this. So they were fully on board with this. And I had a full communication with them during over the years, really. And even when we came to this conclusion, it wasn't really a conclusion first. It was more like a thought that maybe we should just conclude defeat here and give up and rip it out again. So I had conversation with them all the time, and they were very good with this, and they understand it completely. They struggle quite a lot too to find people to actually, pick up the ball and continue this work. And in the end, I think we all concluded that this is the right decision for now. I mean, we haven't shut the door for this idea or this effort or this concept for the future anyway. So who knows? Maybe we will come back to this idea and restart it in the future.
Yeah, there might be some trigger that comes out and it's just a no-brainer to pick it up. That's the beauty of source control. You've got all the history there. I think I've asked this already or we've touched it. What can others learn from this?
The general lesson is basically that it is a fair approach to replace C++ code in a larger project. So I kind of always liked that approach with Rust already back from the days I worked with Firefox, that it's a convenient and decent way to replace components sort of component by component wise, instead of having to rewrite everything into Rust in one single blow. You can instead do it component by component. I still think that's a good way to do it. And I think we proved that it works to do it that way. Other things, I think it's harder because then you get into the weeds of exactly how the API works and how to actually replace a component in a software. And that depends on the particular software, I think, more than anything else.
I think we've covered my last question, which would be, why didn't others step forward to help? And you explained that the knowledge domain here is like 4 different things, and there's the Rust way to do it, there's the C interface, there's the particular bit you're replacing on curl, and then the protocols or the specs involved with that, whether it's authentication or HTTP version 4 when that comes out, etc.
Yeah, and I think just the general lack of a perceived upside of using this. I don't think most people think curl's native solution is bad or insecure and anything. So people wouldn't sort of dream of switching over to this new one anyway. So we're stuck in a land where people using curl, they're pretty satisfied with the existing solution. People using Hyper, they're mostly Rust users. They're in Rust land. They're using Hyper already. They don't use curl anyway. So we ended up in this middle land with no demand.
Yeah, I suppose if this was the hotspot of memory-related security issues or what have you, you'd either take the decision to address them in C and fix them, like you're constantly doing and refactoring to make improvements, or you bring Rust in to do it, but without the sort of raw data to say, given X amount of effort, you'll get Y amount of return. It's hard to really quantify it.
Yeah, we can also come back to the fact that my plan is not to remove the native C alternative anyway, because I think the portability of curl and curl's prevalence on everything, everywhere, is partly due to it being massively portable, and it is this portable because it is written in C. So even if we had kept the Hyper backend, we would have kept the native one as well. So we still need to work on the native one, even if we would have provided a Rust one.
And are you aware of any C projects that you reviewed or listeners could review that do what you already do with Rust and parts, for example? Or
one sort of obvious sibling project to this is I think it's called the mod TLS thing in the Apache web server, where I know Stefan Eising has written a replacement for the OpenSSL using module for Apache that is then using Rust TLS instead when you run the Apache web server, which is pretty much the same take, right? By replacing a slightly different take, but it's the same spirit that they replace a C library with a Rust library in order to do more memory safe operations.
Yeah, I'll put that in the show notes and get that link off you. I think we had a quick chat before we started recording about Rust TLS and how it can use a C library underneath of a TLS implementation as well. So you've always got some C TLS code somewhere, depending on what
Yes, yeah. And that's sometimes a bit ironic, right? When talking about using Rust for memory safety, and then you end up using the C version somewhere in there anyway.
Exactly. Okay, I think I'm going to wrap us up now. I'm really glad we did this show and hope it helps others understand how they can add Rust into their C project, make it a success. And as we discussed, it wasn't a failure. It was just, a feature that didn't have enough demand and benefit and got very, very complicated at the end. Was there anything we missed that you'd like to mention that was a particular highlight or challenge that you solved, or just anything in general?
No, I think we covered most of what I wanted to say. Maybe just to reiterate that Sean and the Hyper project, they were really great and they helped out a lot. So there's really no blame on their side, because certainly not because of lack of energy or lack of commitment from their side. It was basically just, everything we talk about.
So how can people get in touch if they want to ask you particular things, or, maybe investigate some of these tests? Is this now gone until you get some capacity to do it again, or drive appetite?
All this is now gone from Git. So if you want to bring back, you have to bring back an old version and build from source and try it out. I mean, you could do it if you're really interested into what kind of weird problems you can run into when you do this, but otherwise it's not that fruitful, I think. Now we're heading forward instead. So we're looking into, of course, improving curl in every possible aspect and going forward. And if anyone ever think doing it again would be a great idea, that we would, of course, consider getting this back onto the drawing table and do it better next time. But everything that is about curl is, of course, on curl.sc, and just hit us up.
And your blog as well, yeah? Yeah,
absolutely.
I wonder if anything will come along, like a Hyper version 2 that has a particular thing. But I guess with the author of Hyper and, the expert you are, you would have solved it if it was there. Cool. Okay. Daniel, thank you for coming on the show. It's been a real pleasure. This is Gavin Henry for Software Engineering Radio. Thank you for listening.
Bye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.